Hello children, how are you all? We are back with the physics class of class 9 motion, chapter motion part 4. Okay, past 3 videos we were talking about motion, what are the different kinds of motion, what are the terms related to motion, and last class we have dealt with what are velocity, what are the different graphs for distance time graph, velocity time graph and all. Okay, today we will be learning about equations of motion. Okay, we will be learning about equations of motion. Now what are equations of motion? Equations of motion means there are certain equations or formulas by which are derived from these graphs so that it is easy for the further calculation. Okay, so before moving on for the equation of motion, we need to know certain things that we have already learned. Okay, first thing we know that velocity, okay, which is denoted velocity we know, and there are under velocity we know that we have initial velocity. Correct? We have initial velocity which is denoted by u, final velocity which is denoted by v. We also know distance or displacement which is denoted by S. Next we also know acceleration which is change in velocity, correct? Change in velocity with time which is denoted by A, and we also know that time is an important factor for finding motion, okay, and it is denoted by T. Correct. These are the few things that we already know. Velocity we know, which is change in position with time. Okay, that is denoted by change in distance, displacement per unit time. It is known as velocity. And velocity, the starting velocity, whatever a vehicle is having or a body is having or an object is having, that is known as initial velocity, and it is denoted by the letter u. Final velocity is denoted by the letter v. And what is distance or displacement? Distance or displacement is the change in position, okay, and it is denoted by the letter s. Third, we know that acceleration. Acceleration is denoted by the letter a, and what is it? It is change in velocity per unit time, okay. And what is time? Time we know that specifies that is one of the frame by which we we can calculate the change in position or velocity, okay, and it is denoted by T. Okay, so let's move on for equations of motion. So when an object moves in a straight line, okay, suppose this is an object, suppose you or someone moves in a straight line and has uniform acceleration, then if you have uniform acceleration, okay, and you need to move in a straight line, suppose it is, if this is the case, you can relate velocity, acceleration during the motion and the distance covered with time. Okay, how we can relate, we will be seeing in this equations of motion. There are 3 equations of motion. First one is v is equal to u plus at, okay. V is equal to u plus at. What is v over here? Final velocity. U is initial velocity, and a, as you know, is acceleration, and t is the time taken. Okay, and this is also known as this is also known as velocity time relation. Okay, this is known as velocity time relation. This is our equation 1. Okay, now the second one. Second is S is equal to ut plus half at square. Okay, this is known as position time relation, and this is our equation 2. Okay, what is S over here? S is the distance or displacement, and U again we know that it is initial velocity, and T is what? Time taken, and half A again is acceleration and T again is time taken. So this equation is known as position time equation relation. Okay, and the third one is V square minus U square is equal to 2AS. Okay, and this is known as position velocity relation. This is position velocity relation. Okay, now in this video we will be learning how to derive these 3 equations from graph. Okay, and also we will use these equations into the numericals and how we can easily find out values which is not given. Okay, so let's start. So let's derive the first equation of motion, that is V is equal to U plus AT, or we can say that it is velocity time relation. Relation equation. Correct? Okay. Now for this we need to draw a velocity time graph. Okay, because velocity time relation we are going to find. So velocity suppose this is our graph. Okay, and this is the velocity. Okay, this is representing the velocity and this is representing the time. Okay, now as we are talking about uniform acceleration means what? It will be a straight line inclined to the x-axis. Correct? So let us consider, we will not consider it that the body is starting from rest. We will consider that it is having some amount of velocity. Okay, and so we will be starting from a bit higher position. Okay, not from the 0. Okay, let us consider the body was already in motion. Okay, and if this is so, then this is the initial velocity, or we can say this is U. Correct? And if it is this is the final position, that means this will give our final velocity. Correct? And if we just bring it down, okay, if this is the graph, this is the length of the graph, and if we bring it down, then this position will be a certain value of time will be there. Let us consider it as T. Okay, so from here you can see that if this is position O, we can see that this graph we can get one geometrical figure out of it. Correct? So let us name it. Okay, let this be O, this be A, this be B. Let us join this also. Okay, this be C, this be D. Okay, and let this position be E. Okay, so A, B, C, D, O, and this be E. Okay, so from here you can conclude two things. Okay, one is this figure. Okay, if I consider only A, B, C, A, B, D, O, this figure if I consider, okay, then you can see that it can be divided into two parts. First part is a triangle and the second part is a rectangle, correct? Now, another thing you notice that the distance OA, and the distance CD will be equal, right? Distance OA and distance CD will be equal, and what it will be? It will be U, correct? Again, this distance OD and AC, this two distance is also equal, so OD is equal to AC, which is equal to, and what is this, what is the length of this figure? It is T. Okay, from here to here this value is what? This is T. That means this value is T only. Okay, so this will be T, correct? Now we need to, now let's start with this one. Okay, okay, now we know this length we know, this length we know, this length we know, this length we know, so we can find the area of the rectangle. Now what about the triangle? We know the base, but we do not know what is the height, correct? So we have to find this. Okay, so what is BD? BD is actually BC plus CD, correct? Now what is BC? BC is V minus U. What is CD? CD we already know is U. Sorry, this portion, this one only we are going to find. No, sorry. So what is BD? BD is from here to here. What is the distance? Okay, what is, how many unit it is? It is V. Okay, and BC only we are going to find out. Sorry, BC only we are going to find out, correct? Now, so we can say that BC is equal to V minus U, correct? Now, if I consider BC, okay, BC means what? This, okay. If I consider acceleration, okay, if I want to derive from this graph, what it will be, my acceleration, what it will be? Change in velocity, correct? Change in velocity by time, right? Now what is change in velocity over here? Change in velocity is this portion only, BC, correct? So BC by T is equal to A, or we can say that BC is equal to AT. Understood? Now this value of BC I am going to substitute over here. So what it will be then? Instead of BC, I'll be writing AT is equal to V minus U, or I can say V is equal to U plus AT. So we have successfully derived the first equation of motion. So one quick recap of it. First we are going to draw the velocity time graph, okay, and we are going to consider the body is in uniform motion, and it will definitely not start from zero. It will be having a certain amount of initial velocity. Some magnitude will be there which will be not equal to zero, okay, and as the body is in uniform motion, it will have one final velocity also after it completes the motion, okay. Now if I draw the graph, okay, I can, from the area covered by the graph, this is the total area covered by the graph. What is it? OABD. Okay, this is the total area covered by the graph, and this total area can be divided into two portions. See, the first part is a triangle and the second part is a rectangle, and from there we can find out certain values. That is, for this rectangular area, if I want to find the rectangular area, what do I require? I require length and breadth. So length means what? This portion, okay, AC, and AC is equal to then what? OD. So OD and AC both are equal, and the magnitude of it will be T, as this is the from here to here, if it is 0th position, from here to here the unit covered will be T, okay. And for the breadth, if I consider this as the breadth, so OA and CD will have the same length, means same magnitude. So OA is equal to CD, and what will be the magnitude? It will be the unit covered by the graph, that is U, okay. From here to here it is U, okay. So for the triangles area, I need to know what? Base and height, correct? Now base I already have known, and this BC I am going to find out how much, okay. From here you see, we can say from the whole line, if I consider, this is BC plus CD, okay. This BD line is BC plus CD, and what is BD? BD is V, and BC I am leaving it as it is, and CD is what? CD is this one, okay, this small portion unit covered, that is U, okay. From there I can get BC is equal to V minus U, correct? Now then how we can relate, as this is velocity time graph, we can relate it to acceleration. So we can't use BC is equal to V minus U, no. So for that, acceleration, we know that change in velocity by time, correct? Now what is change in velocity over here? That is V minus U. Initial velocity minus final velocity is the change in velocity, and what is that? That is BC, okay. And as this is BC, so BC by T is equal to A. From there we can say BC is equal to AT, and this AT we are going to substitute back into the equation that we have got, and hence we will get AT is equal to V minus U and V is equal to U plus AT. So this is our first equation of motion from the velocity time equation, relation equation. Now next is the position time relation, okay. Position time relation, and we will be talking about the same graph, okay. Now position, here we will be talking about distance. Okay, and now what is distance covered? How can we calculate distance covered from a velocity time graph? Yes, we can calculate distance covered from a velocity time graph by the area covered by the graph. Okay, so this is the, if this is the graph, we will not consider the portion which is outward of that line. Okay, how much portion that line is covering towards the graph, okay, towards this axis, that will be the distance. Okay, so here we can write distance, if distance is area of OABD, correct? Area OABD gives the distance. Okay, and what is area OABD? We have bifurcated into two portions. One is the area of rectangle. What is the rectangle? OACD. OACD. And area of the triangle, which is ABC. ABC. Correct? Now, step 1. Okay, we will be talking about the area of rectangle. Now here we already know what area of rectangle means, length into breadth. What is the length? Length is AC, or we can say that it is OD. Okay, so AC equal to OD, whatever it is area of OACD is AC into what will be the breadth? OA. Okay, so what is AC? AC is T, and what is OA? OA is U, so we can say it is UT. Okay, area of the rectangle is UT. And what is the area of the triangle? Area of ABC is what? We know half base into height. What is the base? Base is AC. And what is the height? BC. So what is BC? BC we have already got, no? BC is equal to change in velocity, which is change in velocity, which means A into T. We have already got in the previous equation, no, that BC is equal to AT. Correct or not? BC we have got, no, BC by T, A is equal to BC by T. From there we can derive BC is equal to AT. Correct? So that we are going to substitute here. Okay, it will be half. What is AC? AC means again T. And what is BC? It is AT. So we can say half AT square. So we are going to join this together in step 3. So what is our step 3? S is equal to, instead of area OACD, we will be writing UT. UT. And instead of area ABC, we will be writing what? Half AT square. So this is our equation of motion number 2, which is also known as position time relation equation. Understood? Easy now? Yes. Now we will be talking about the last equation of motion, which is also known as position velocity relation equation. Okay, position velocity relation equation. instead of position time it will be position velocity. Okay, now again this figure. Okay, now we will be, as we are talking about position, which means we will be again using distance. Okay, and now instead of bifurcating into two figures, we will be considering the total figure and we will be trying to find out the area covered. Okay, now you can see from this figure OABD, this is actually what? This is actually a trapezium. So area OABD, okay, or this is the area of a trapezium. Now we will not consider it as two separate figure. Okay, we'll consider it as a same figure. Okay, this is a total of one figure only we'll consider. Okay, and we are going to find out the area. Now what is area of a trapezium? We know that sum of the parallel sides by 2 into the height. Sum of the parallel side into height. Now what are the parallel sides? This one and this one, and this is the height. So sum of the parallel side, which means what? OA plus BD by 2. And what is the height? Height, if I consider this as the height, because if these two are the parallel side, I can't consider this as the height. This will be the height, either AC or OD. Now taking AC or OD, both are equal. That we have already proved over here. We have already found out. So we can take any one. So I'll be taking OD. Okay. So OA means what? U. BD means what? V by 2 into OD means what? T. Or we can say now from here this BC is equal to 80. Okay, what is BC that we have found out previously? BC was V minus U, correct? V minus U. So what is T from there? T, if I want to find out, so from here, okay, from T what it will be? T will be, if A is equal to BC by T, then what is T? T is equal to T equal to BC by A, correct? Now what was BC? BC was V minus U, right? V minus U. So which means V minus U by A. Okay. Now this I will be substituting over here. Okay. Instead of T, I'll be writing that. So it will be V plus U, which was previously, which was there already. Okay, V plus U. Instead of T, what I will be writing? V minus U. And 2 was already there, and just beside it you have to multiply A, because A is in the denominator part. When two denominator we are putting together, we will multiply. So from here you can see V plus U, V minus U, which means A square minus B square formula. So we can say V square minus U square by 2A. Okay, which means also if I take 2A and multiply, if I want to make it a linear equation, we can say that 2as is equal to v square minus u square, and hence we have got the third equation of motion. And what is our third equation of motion? 2v square minus u square is equal to 2as. So we have got three equations of motion from the graph, and we have also seen how to first we have taken the graph. First we have started by finding the value of v, okay, from this graph. Then second equation, how did we get? We just bifurcated, we truncated this whole graph, area covered by the graph. Okay, this is the area covered by the graph, because the line is when a line is there, we have to see how much portion it covers, okay, not outside of it, okay, how much portion it covers towards the axis, okay, that is the area covered by the graph. And what is it? First we have seen by dividing the whole area covered by the graph into two portions. One is rectangle and triangle. From there we have derived the second equation of motion, and for the third equation of motion, what we have done, we have taken this whole area as a area of trapezium, and we know that area of trapezium is sum of parallel side by 2 into height. And previously we have already found out what are the different terms related to the graph, and also what is the base, height, and all those things we have found out. And from there BC, from the value of BC, we have always been talking about t, okay, but we haven't found out what is t. In other terms, how to find out t. So from there, for that we have found out a is equal to bc by t. So instead of we had made t the subject of the formula, and from there bc we knew v minus u. From the first equation while deriving, we have seen v minus u, and so hence we can say t is equal to v minus u by a, and that we have substituted again in this problem, and we have found out the third equation of motion. So that's all for today's class. I hope you have understood how to derive equations of motion. It is very easy. In the next class we'll be solving the problems related to equations of motion, and we'll be dealing with more. Okay, that's all for today. Thank you for watching. So for your assignment 3, I have a problem, that is a speed time graph is given of a car is given in the figure, and you see that speed is given and time is given, so you can find distance. So first question is, find how far does the car travel in first 4 seconds. Okay, so how far means you have to find the distance, and see for distance means 4 seconds. You will find there 4 second. What is for the 4 second, how much speed is there adjoining? You will just go straight up and you will find how much speed what is the value of speed at that point where the graph intersects that point. Okay, and what is the point of intersection of time and speed, okay, on that graph? You will find that, and from there you will get speed and time, and from there you can easily find distance. What is distance? Speed is equal to distance by time. From there you know distance is equal to speed into time. Okay, next is shade the area on the graph that represents the distance. Okay, so you have to just shade the graph that represents that distance. So what did I tell? That distance will be always. So next is shade the area of the graph that represents the distance traveled by the car during that period. So you have to shade the area, and what did I tell? The area covered by, always distance is the area covered by the graph and towards the axis. Okay, that is the distance. Next question is, which part of the graph represents uniform motion of the graph? You know that uniform motion means there will be no change. Okay, no change in velocity or speed with respect to time. So from there you can find easily which part, and you have to just mention it with pencil or pen. You have to do it in your classwork copies. And that's all for today. Thank you.